Dear friends, welcome to the next session for real-time embedded systems. In today's session, we will talk about scheduling algorithms or scheduling in real-time embedded systems. So, talking about this session, we will learn about real-time embedded systems, scheduling algorithms, the different types of real-time scheduling algorithms, the online and offline scheduling algorithms of real-time embedded systems, etc. So in real-time operating systems, which is also known as RTOS, most of the tasks are periodic in nature. So periodic data mostly comes from sensors, servo control and real-time monitoring system, your real-time embedded system being one of them. In real-time systems, this periodic task utilize most of the processor computation power as well as the processing capacity. A real-time control system consists of many concurrent periodic tasks having individual timing constraints. So these timing constraints includes, so I'll write it for you, the timing constraints includes first of all the release time, which is represented as Ri. We have the worst case execution time. That means under which worst case scenario will the task be executed, worst case execution time, which is represented as Ci, the period of execution period, which is represented as Ti, and the deadline. That means the limit to which you can execute your process. So it is represented as Di. So for each, these things will be calculated for each individual task, which is represented as Ti. So real-time embedded systems have these constraints linked to the output of the system. And these scheduling algorithms are used to determine which task is going to execute when more than one task is available in the ready queue. So suppose we have multiple tasks T1, T2, T3, dot dot dot. So it will determine, all these constraints will be determining which task will be executed when. And all of this has to be present in the ready queue. So, the operating system must guarantee that each task is activated at its proper rate and meet its deadline. We have several types of operations or several types of tasks which a processor might be processing. So based on the requirement, we have to understand the various constraints and then allot the processor to that particular task. Talking about these real-time systems, they can be categorized into something which we have already been doing, which is real-time operating systems. Then we have embedded operating systems. Embedded operating systems, such type of operating systems are a very common phenomenon or a very common process or a very common system in your embedded systems. And we have embedded system applications. Embedded system applications. So all of these three types of categories will basically be depending upon the processor to process different types of activities which can be, or different types of tasks which a system might be receiving. Now, to ensure that the operating system guarantees that each task is activated at its proper rate and meet its deadline, some periodic scheduling algorithms are used. So, talking about the scheduling algorithms, it can be categorized into several types, primarily two. So we will look at the hierarchy of scheduling algorithms, so of your real-time systems. So scheduling algorithms can be primarily categorized into static scheduling or dynamic scheduling. Dynamic scheduling. So static scheduling is offline and clock driven, whereas dynamic scheduling is online and it happens spontaneously. So static scheduling, which one of the very common scheduling algorithms used here is round robin. We have done round robin in our traditional operating system concept, scheduling concepts as well. So round robin, which is represented as RR, and we have dynamic scheduling algorithms again subdivided into two types. One is the priority driven and the other is the quality driven. Priority driven and quality driven. For priority driven, we again have two different categories of it. One which is having a static priority and the next one which is having a dynamic priority. Dynamic priority. Among static priority, the one of the most common algorithms which is used is the rate monotonic algorithm or rate monotonic scheduling, which is represented as RM. And among dynamic priority, we have earliest deadline first. Earliest deadline first, which is also represented as EDF. Now these scheduling algorithms have concepts or are executed based on some very traditional scheduling concepts which we have already done before in our operating system scheduling concepts. So now let us talk about each of them in brief. So the first one, which is your offline scheduling algorithm. Offline scheduling algorithm is a type of algorithm which selects a task to execute with reference to a predetermined schedule. So they have a schedule based on which the task will be executed. Let us say this schedule will be repeating itself after a specific interval of time. So repeated execution will be there depending upon time interval. Repeated execution, I'll just write this properly. So repeated execution after a definite time interval. So this repeated execution, let us take the example like we have three tasks TA, TB and TC. So TA will always execute first, followed by TB and then followed by TC. After that, again if it is needed, TA will be executed, then TB and then TC respectively. So this way it is following a definite schedule of execution after every interval, after a definite interval of time. Let's say we have 1 second of execution for between each of the executions. So it repeats itself after every interval of time. Yes, it has a predetermined schedule and it will be repeatedly executing after definite intervals of time. Then we have what we know as the online scheduling. So, talking about online scheduling, so online scheduling is again classified into two types, which is quality driven and priority driven. So, quality driven, and it depends upon priority driven. Talking about online scheduling in general, a task here will execute with respect to some priority. Now, this priority is determined in real time according to specific rule, and priorities of these tasks may be changed during the execution. So the online scheduling this online scheduling algorithm will be strictly sticking to the priority associated with the quality and the priority itself, and they are more flexible because they can change the priority of tasks on runtime according to the utilization factor of the task. So here the utilization factor plays a very important role, and based on the utilization factor of the tasks, the priority can be changed and the other tasks could be executed. So priority can be changed here during the execution of the task. Now, talking about the fixed priority algorithms. So in priority driven algorithm as well, we have different types of algorithm or categories, which is your static priority and the dynamic priority. So fixed priority or the static priority is a type of priority driven scheduling algorithm, and this is a dynamic, that is a online, not a dynamic, it's an online scheduling algorithm. So this fixed priority algorithms, if the kth in this particular algorithm, if the kth job of a task T1, let's say the kth job of task T1 has higher priority, so has higher priority, or let's represent it in something like this. So it has a higher priority, than the kth job of task T2. So kth job of task T2 according to some specified scheduling event, then every job of T1 will always execute first, then the job of T2. So first of all, we have to determine what is the level of priority between the jobs, and if we understand that job of task T2 has lower priority than T1, then at every instant of time, T2 will be executed later than T1. That means T1 has to be executed first. So on the next occurrence of the priority, again, if for in the second instance, so this is the first instance, in the second instance also the same rule will apply, and T1 will be executed first and T2 will be executed followed by, following T1. So more formally, if the job J, more formally, if the job J 1 comma K of task T1 has higher priority than the second job, which is J2 comma K of task T2, then J1 comma K plus 1 will always has higher priority than J2 comma K plus 1. So this we have to understand. And one of the best example for your fixed priority algorithm is the rate monotonic. I'll write it here. So rate monotonic scheduling algorithm. Rate monotonic scheduling algorithm. So we have to understand that we first have to determine the level of priority between one instance of the job, and the same instance of priority will be followed for the rest of the jobs. The next we will talk about is dynamic priority algorithm. So as the name suggests, dynamic priority or dynamic has no such predetermined rules. So in dynamic priority algorithms, different jobs of a task may have different priority on the next occurrence. So it may be higher or it may be lower than the other task. And more formally, if you represent that we have job 1 comma k of task T1 is greater than job 2 comma k of task T2, then essentially this next instance need not have the same. It might be lesser than what it is in the first instance. So next time the second job might be executed first. So here the priority of the task changes at every point of time. So there is no such fixed concept of having any fixed priority. No fixed priority. So at every instance the priority might change. Now when we are talking about the processor utilization factor, so processor utilization factor is represented as U, and let me write it down first. So processor utilization factor, utilization factor. So this factor is extremely important in determining the performance of a processor, and for a given task set of n periodic tasks, the processor utilization factor U is the fraction of time that is spent for execution of the task set. Now, this processor utilization factor can be represented as summation of I to n, where I is starting from 1 to n, and Ci by Ti. So this we are calculating for a set of n periodic tasks. So if we have n periodic tasks, the processor utilization factor U is the fraction of time that is spent for the execution of the task set. So if Si is a task from the task set, then Ci by Ti is the time spent by the processor for the execution of Si. Similarly, for the task set of n periodic task, so which is ranging from I to n, so n periodic task, it is given by the fraction of time which is spent for execution of the task set. So Ci basically is representing the execution time, and Ti will be the time period. So execution time by the time period given. Similarly, for the task of processor n periodic set, we can represent the utilization factor as this. And processor utilization is greater than 1, then the task set will not be schedulable by any algorithm. So we have to understand that if U is equal to 1, that means the processor is utilized 100%. Processor utilization is 100%. So if it is greater than, if any of the task has the processor utilization which is greater than 1, that means we will not be able to schedule that task or we will not be able to schedule that particular activity by any algorithm. So today we have learnt about several factors which are associated with the scheduling, starting from the timing constraints which are associated with each of the task, and which determines what type of which particular task will be executed when, followed by the different types of applications, and then we also categorize different scheduling algorithms. We talked about offline scheduling, online scheduling, fixed priority algorithms, dynamic priority algorithms, and processor utilization factor. So in the next class or in the next session, we will be talking about some of the scheduling algorithms which are very essential in scheduling the various tasks by the processor. So thank you, and we will meet again in the next session.